in this episode how to differentiate implicit equations including product and quotient coming up. Hey guys, in my previous video I came up with some techniques and tips on how to do implicit differentiation, such as logarithmic differentiation can be used as a one-off technique to differentiate functions implicitly. Now, sometimes your expression, your function that has to be differentiated implicitly, including product or quotient of its terms. So you need a special technique for this. Basically, you need to use one of the laws, or sometimes it could be a combination, product law or quotient law that actually came from derivative laws. So if you are not familiar with derivative laws for derivatives, so you can, for differentiation, you can check out my other videos. Here I have listed a couple of different terms that your expression might contain, might made of. Let's take a look at that. For the first one, if you are given something like e exponent raised to the x cubed y. Alright, how to handle that? First of all, as a good rule of thumb, you differentiate it, you take the derivative of exponent, as you are given an exponent, followed by a product law, as your exponent contains a product. So actually you use a chain rule if you have heard about this, because you have a composite function. Your function is made of e, which is your outside function, and this product, which is basically exponent of power itself, namely x cubed y. So apply chain rule followed by a product law. The derivative of e to the x, e to any power, is just itself the same function. So for this one, you would get just e raised to the x cubed y, since the derivative of e to the any power is e to this any power, gets multiplied, so we use the chain rule, and you need to take the derivative of exponent, so you need to take the derivative of x cubed y. Since x cubed times y, so x cubed times y is a product, so you use a product law. So u is your first term, so u is your x cubed, this is your u, and y is your d. So apply it straight away. So the derivative of u prime, is 3x squared times y. So you leave your v as is alone, plus, keep going, u as is, u is x cubed, gets multiplied, v prime. The derivative of y is just 1. but this is your y term. So, and we differentiate implicitly. We have to tack on, we have to attach dy dx. So basically, dy dx here. So I'm not going to write out 1. So this is for the first one. Moving on, how about this one? Alright, x squared divided by y. So you have a quotient, apply a quotient law. So quotient law says, you take the derivative of u, so x squared, this is your u, so this entire x squared, this is your u, and y is your v function. So u prime, so x squared prime, the derivative of x squared leaves you just 2x, gets multiplied by v itself, y. Subtract off minus always. U is this, so you're going to rewrite x squared, and you multiply by v prime, the derivative of y. The derivative of y is just 1. Okay? But because you have this term containing y, so you have to add, you have to tack on dy dx. And your bottom is just v squared, so you're going to write y squared on the bottom. One little kind of side note. X squared, to be precise, divided by y can be treated as a product as well. It can be treated as x squared times by y, 1 over y. So actually to this one, this product law is also applicable. So you can use it to differentiate, and you would come up with the same answer. Moving on, how about this one? You have root or square root of a product. Underneath the root, x times y, a product. So you have a root, apply the derivative of a root. The derivative of a root is 1 over 2 over what you have inside, what you have under the root. So from where it comes from? Basically it came from a basic power rule. So your root can be written as a 1 over 2 power, and you can derive this formula from a basic power rule. Now you take this derivative of a root, which is 1 over 2 root of what you have inside, whatever you have inside the root symbol. This one gets multiplied, but because you have a composite function, so you have this product under your radical symbol, under your root. So all you need to do is just apply the product law for this inside. So the derivative of x is just 1, derivative of u. So v is your y. So gets multiplied by y plus the derivative of v prime is just 1, leaving you as is, alone, untouched. But because you have y term, so your term containing y, you have to attach dy dx at this point, at this stage. So you can ignore these ones. So this is your derivative for that term. All right. Now let's grab this one, natural logarithm of product x and y. So first of all, what pops out at you? Natural logarithm. So take the derivative of natural logarithm. So it's just 1 over the argument. So 1 over xy in this case, gets multiplied. So again, keep in mind, you use chain rule followed by a product rule. Gets multiplied by the derivative of a product. Apply a product law. Derivative of x is just 1 times y plus x. Derivative of y is just 1. But because you have y, dy dx. Well, at this point, at this stage, I would simplify it down, because when you open up, when you remove the parentheses, y and y in this case cancel. So you would end up with 1 over x. And for the second one, x's would cancel. So plus all right, moving on, the next one, you have cosine of product x times y. The derivative of cosine is negative sine, so derivative of sine is cosine, the derivative of cosine negative sign. It's kind of cyclical. So again, the same, a good rule of thumb. Negative sign of this product gets multiplied the derivative of the product. So basically the same thing. Alright, this is for cosine x times y. Alright, one special dish, one special meal. It's like a restaurant and I'm your waiter. This one looks delicious, very absolutely delicious. Alright, let's get taste of it. You have product on the left side. Use your product law. Okay, y is u, and e to the x is uv. The derivative of y is just 1, and you have to attach dy dx. Times e to the x plus u y. Derivative of e to the x is e to the x equals. Moving to the right side, x times y, product pops out at you. Use a product law. Derivative of x is 1 times y times v plus x. Derivative of v is 1 times dy dx. Plus y squared. Apply power rule to y dy dx. And the derivative of 3 is just 0. I'm going to just ignore it. Alright. 1, 2, and 3. 3 terms containing dy dx. All you want to combine them together. Let's have a party. Move them together. So this term and this term I'm going to bring to the left side by subtracting them off. Moving to the right side. I'm going to keep y on the right side, so I'm going to collect all terms that are not containing dy dx, and this term y times e to the x, I'm going to move it by swapping the sign in front. Now, dy dx, dy dx, dy dx. Factor it out, take it out. So use this trick to simplify it down. Parentheses, what's left behind? Now, the final step. I guess not the final, but anyway, divide out, yeah? So this term has attached to dy dx. We want to isolate dy dx. We want to make it subject as a formula. Get it along on the left side. Divide it out. Look at this side. So you have something like y minus y times e to the x. So y has attached to both terms. We can pull it out. We can snag it out. So your top becomes just, and you divide by this whole parenthesis. I told you, this is your special meal. I know, guys, everyone hates maths. But if you like my video, please hit like, share with your friends, leave the comment down below, smash that subscribe button so you will not miss my new videos. Train your brain.